Welcome to lesson 3.4. Today we're going to go into exponential and logarithmic equations. So before we get into examples of this, we're going to first go over a few techniques that will help you when you're trying to solve these equations. So the first technique to do is start with any basic algebra that you can possibly do. If you can add, subtract, multiply, divide, start with that first. Try and make that equation as easy as possible. Now we're going to go into three different types of equations that you're going to see. The first is when you have the same base on the equal sides, on both sides of the equal sign. So if you have the same base, like in our example here, we have 2 to the 2x equals 2 to the 1. Our base is the same on both sides of the equal sign. All we have to do then is set our exponents equal to each other. So we would set 2x equal to 1 and solve. And when you solve for x, you would get x equals 1/2. So that's a pretty basic problem. We're going to go into another more complicated example later on in the lesson. But I just wanted to give you that first technique so that way you kind of have an idea of how you would go about solving these. The next technique is if you have an exponent with a base of a, and a could be any base, rewrite both sides as a logarithm with that base. So the reason why we're doing this is that we're wanting to cancel out our exponent. So we have an exponential equation with a base of 2 here. So we can rewrite this as log base 2 of 2 to the x equals log base 2 of 8. And the reason for doing this is that we know from our properties that the log base 2 of 2 will cancel and you're just left with the x. That's one of our properties that we learned earlier on in this chapter. So now you have x equals log base 2 of 8. And then you would go ahead and solve it from there. You can use your change of base formula to plug it into your calculator or things like that. And we're going to go into some more examples and actually solve this through later on in the lesson. Again, we're just going over the techniques right now. The last type of problem that you're going to see is the opposite of what we just saw. So instead of having an exponential equation, we're going to have a logarithm with a base of a. So if this is the case, you can rewrite both sides as an exponential equation to get that log to cancel out. So again, we've got a log base 2 of x equals 3. So if we raise both sides to an exponent and use 2 as our base, on our left-hand side, we're going to have that cancel out again. Because remember, 2 to the log base 2 cancels. That's meaning 2 to what power will give you 2, and that becomes a 1. So you're just left with your x here. So you would rewrite this as x equals 2 cubed. And if that's the case, you can solve that out and you get x equals 8. Okay, so those are the techniques that you're going to use for the following examples. And the rest of this lesson is just that. We're just going to go through examples so that way when you come to class, you'll have some examples down and the homework won't be so difficult. So our first example, we're going to set our exponents equal to each other. The reason for doing this is we've got the same base, and just like our technique said on the previous slide, when you have the same base, set your exponents equal to each other. So that means we have negative x squared equals negative 3x minus 4. So remember from your algebra days, you have to set this equal to 0. So we're going to bring our x squared over here by adding x squared to both sides. So now we have x squared minus 3x minus 4, and this equals 0. So now we're going to factor our polynomial here, our quadratic equation that we've got. So we have 0 equals x minus 4 times x plus 1. So we can see from our algebra that we've done here that x can equal either 4 or negative 1. For our above equation to be a true statement. Okay, so now we're going to go on to the next example. And remember what I said from the first slide. The first step that you're going to take is do any basic algebra that you can do. So we can divide both sides by 3. And that simplifies our equation. So now we have 2 to the x equals 14. Okay, so we've got an exponential equation. So again, our technique that we learned is that we're going to take the log of the base of our exponential equation. So we're going to rewrite this as log base 2 of 2 to the x equals log base 2 of 14. And remember, if we have log base 2 of 2, that cancels, and you're just left with your exponent. So now we have x equals log base 2 of 14. So we can solve this using our calculator by doing a change of base formula. You can also use, if you happen to have the program in your calculator, you can use the log base formula, but if you don't happen to have that, we're going to use a change of base formula. So we're going to rewrite this as the natural log of what we've got here. So remember, our change of base formula is natural log of x, which would be 14, over natural log of our base, which is 2. So when you plug that into your calculator, you'll end up getting 3.807 as your answer. So x equals 3.807. Okay, let's move on to the next example. So now we've got e to the x plus 5 equals 60. So again, do any basic algebra that you can. So we're going to subtract 5 from both sides. So now that gives us e to the x equals 55. So we've got an exponential equation. That means we're going to take the log of both sides. And in this case, we're going to take the natural log because our base is e. So rewriting this, we have natural log of e to the x equals natural log of 55. So natural log of e cancels, and you're just left with x. Because remember, natural log has a base of e. So your natural log of e will cancel, and you're just left with x. So x equals natural log of 55. When you plug that into your calculator, you'll get 4.007 as your answer. Okay, let's move on to the next example. So this one we're going to solve by raising both sides to an exponent with a base of 5. And the reason is because we see that our log has a base of 5. But again, before we do anything, let's see if we can simplify using algebra. We've got this 2 in front here. We can divide both sides by 2. So that gives us log base 5 of 3x equals 2. So if we raise both sides to 5, we end up with 5 log 5 of 3x equals 5 squared. Because remember, whatever you do to one side, you have to do the other side. So our log of 5 with our exponent will cancel, and we're just left with 3x. So now we get 3x equals 5 squared, but we know that 5 squared is 25. So 3x equals 25. We solve for x by dividing by 3. So x equals 25 over 3. So hopefully you're starting to get the hang of these now. And when it comes to the homework, you'll get a lot more practice doing these as well. We're going to go on to one last type of equation. And this is a word problem. So on this one, we're going to use our continuously compound equation, which, as you will remember, is PERT, P-E to the R-T. So let's write that down. We have A equals P-E to the R-T. And previously, we've been solving for A. But in this word problem, we're actually going to solve for T. So let's go ahead and find out what this problem's looking for. It says, how long will it take for an investment of $2,500 to double when it is compounded continuously at a rate of 12%? That means we're solving for T, because it's asking for how long. So we are solving for T. So we're going to be using the techniques that we just learned today to solve for this. The one thing that we don't have written down here is we actually know what A is, because we want our initial investment to double. So that means that A equals $5,000. So now we're going to plug everything that we have in to our equation. And the reason why we're using PERT instead of the other equation is because this is compounded continuously. So we have 5,000 equals 2,500 e to the r. Our r is 0.12, so we have 0.12 and then t. And remember, we are solving for t. So back to our techniques. Is there any basic algebra that we can do? Yes. We can divide both sides by 2,500. So now we have 2 equals e to the 0.12 t. Okay, so now we have an exponent here, an exponential equation. So we're going to take the natural log of both sides. And the reason for that is because our exponential equation has a base of e. So we get natural log of 2 equals natural log of e to the 0.12 t. So remember, natural log of e cancels, and we're just left with our exponent. So we have natural log of 2 equals 0.12 t. And when you divide both sides by 0.12, you're going to get t equals 5.8. And we know that that's in years, because these equations are always done in years. So there's your answer. So that's it for today. Hope you guys enjoyed this, and we'll go over more examples, or you'll get more practice with this in class with the classwork. Have a great day. See you guys later. Bye-bye.